Welcome to the Deep Dive. Today we're tackling a problem that's really, well, it's a problem born of success. I mean, the sheer just impossible volume of medical knowledge out there now.
It's incredible.
Yeah, we're talking about a field that completely transformed in the 20th and 21st centuries. You have breakthroughs like microbiology, advanced pharmacology, medical imaging, genomics.
And of course, the massive electronic health records we now have.
Yeah.
All that data.
Exactly. And the result is, well, no single human being, no matter how dedicated or brilliant they are, can possibly master all of it.
Not anymore.
Yeah.
The idea of that comprehensive generalist, it just sort of shattered under the weight of all that information.
So that's our mission for this deep dive. We're going to explore this idea that artificial intelligence is emerging not just as another tool, but as a unifying force, something that could stitch all that knowledge back together.
Right.
We're looking at what some are calling the birth of the AI-augmented generalist physician.
And what's really fascinating here, and our source material makes this very clear, is that we aren't talking about a glorified search engine. This is something else entirely.
Yeah.
It's being framed as an active cognitive collaborator. It's a technology that could bridge knowledge gaps that have existed for generations. And that forces us to ask, what does a doctor's job even look like anymore?
Let's start with a bit of that history then, because medicine has always been a knowledge-driven field, right?
Yeah.
It's about understanding anatomy, physiology, pathology.
And then synthesizing all that data to make a decision.
Right.
If you track the progress, you see the Industrial Revolution was this great formalizer. It's when we got standardized medical schools, hospital-based training. It brought in rigorous scientific methods.
And that structure worked for a long time and allowed knowledge to be taught and applied systematically.
For decades, yes. But then the pace just exploded.
Mid-20th century.
Exactly. The amount of research, the clinical discoveries, it just accelerated to a point where the old curriculum couldn't possibly keep up. It became cognitively impossible for one person to hold it all in their head.
And so specialization was the only way forward.
It was the only rational response.
Yeah.
If you couldn't master everything, you had to master one small piece of it to maintain any real expertise.
And that led to incredible advances in treating very specific, complex diseases.
Absolutely. But it came at a huge cost. It introduced this devastating systemic inefficiency. It fragmented everything.
Then that fragmentation is what patients feel every day. I mean, you know that feeling, right? When you have a condition that touches on, say, 3 or 4 different systems.
Chronic pain, maybe some fatigue.
Yeah, and maybe a weird metabolic issue. So you get sent into this referral cascade. First the cardiologist, then a rheumatologist, then you wait 3 months for an endocrinologist.
And each one is just looking at their own organ system. Nobody is owning the complete picture. And our sources really highlight this. For patients with these multi-system conditions, that fragmentation creates communication barriers, you get redundant testing, and worst of all, huge delays in getting a real diagnosis.
So that is the fundamental flaw in the modern system.
It is. And it's the precise problem that AI seems uniquely positioned to finally solve.
Okay, so that brings us to the solution. How does an AI actually do that? How does it integrate all this disparate knowledge from all these subspecialties when the human brain just can't?
Well, an AI system, especially one running on large language models and trained on, vast clinical data sets, it doesn't have our limitations. There's no cognitive fatigue. There's no limited memory.
It just takes it all in.
It takes the entire body of knowledge from cardiology, oncology, rheumatology, pharmacology, all of it, and integrates it into a single framework. And not just a database, a reasoning framework.
So we're not just going back in time to the old generalist who knew a little about a lot. This is something new. The sources call it a distributed cognition framework.
And that phrase is so important. It's really key.
Break that down for us.
Think of it like this. The human physician's brain is still the central processor. It's where the empathy comes from, the critical judgment, the understanding of the patient's life.
Okay.
But the AI acts like an integrated external nervous system. It supplies this boundless, perfectly organized, specialized data, and it can run millions of calculations in a second to find patterns that a human might take years to see, if ever. The intelligence is distributed across both.
That makes it much clearer. Let's make it concrete with that patient example from the source material, the one with those complex, overlapping symptoms.
Right. So imagine that patient walks in. They've got that tricky cluster of symptoms. Persistent, really debilitating fatigue, shortness of breath, their joints are swollen, and they've lost weight without trying.
In the old system, that's the referral nightmare we just talked about.
The referral nightmare. Weeks, months go by. Each specialist looks at their piece of the puzzle and says, well, it's not my area. And they often miss the root cause connecting everything.
So how does the AI-augmented generalist handle this differently?
They turn to the AI tool right away. The system can immediately cross-reference that patients' specific labs and symptoms against patterns it's learned from millions of other cases.
Looking for connections.
Connections between, say, a rare inflammatory condition, cardiac issues that show up in autoimmune disease, and certain metabolic markers, things a single human just wouldn't connect quickly.
And that's the aha moment.
That's it. The AI provides a synthesis. It might identify a pattern connecting systemic autoimmune inflammation with some early-stage cardiac dysfunction and a secondary metabolic problem. It suggests a holistic diagnosis that no single specialist would have felt confident making on their own.
And that's the value. You reduce diagnostic errors, you cut down on all those unnecessary referrals, and you can start treatment so much faster. The AI basically restores the possibility of holistic care.
And if that's the reality, if AI is handling the heavy lifting of memory and pattern recognition, then medical education, it has to change fundamentally.
Right, because just memorizing diagnostic criteria, that's quickly becoming obsolete.
Completely.
So the human role pivots. You're no longer the keeper of all knowledge. You become the master orchestrator of this collaboration.
Perfectly put. Curricula's have to shift from that old model of rote memorization. The focus has to be on understanding, on critically applying, and using knowledge in partnership with the AI. It's about judgment, not recall.
So what are the new core skills? The sources lay out a kind of checklist for the next generation of doctors. 4 key competencies.
The first one is AI system proficiency. And this is much more than just knowing which button to click.
Sure.
It means you have to understand the underlying algorithms. How are they trained? What data do they prioritize? And most importantly, you need to be able to critically assess what they spit out.
You can't just take the recommendation blindly.
Never. If the AI suggests an aggressive treatment, the physician has to know why and the statistical confidence behind that suggestion.
Which leads right into the second point, collaborative problem solving. This is the art of it, really, taking those AI insights and integrating them into a real, messy, human clinical situation.
Using the AI not as an oracle, but maybe more like a sparring partner, the human physician always has to be the final, critical reviewer of the data.
Okay, and number 3?
Number 3 is contextual adaptation. This is maybe the most human part. AI gives you probabilities. It gives you patterns based on huge populations.
The statistical answer?
The best statistical answer, yes. But the physician's irreplaceable role is to adapt that general insight to the specific patient sitting in front of them, their social situation, their other health problems, their emotional state, their tolerance for risk.
The human provides the best personalized answer.
Precisely.
And that brings us to the 4th and final competency, which sort of underpins everything else. Robust ethical reasoning.
This is critical. It's about ensuring that we use these incredibly powerful new tools responsibly, that it's always patient-centered, and that human safety is the absolute priority, and that is probably the hardest one to teach.
And it's a perfect transition because introducing these AI systems, as revolutionary as they are, also brings in some pretty profound risks.
Oh, absolutely. Risks that the next generation of clinicians have to be trained to spot and to mitigate.
One of the biggest ones, and it touches on that ethical reasoning piece, is bias and transparency. How do we make sure these tools are actually equitable?
It all starts with the data. It has to. If the data sets used to train the AI aren't representative, say, they overrepresent one demographic.
Or underrepresent a certain disease in another.
Yes, then the AI will just perpetuate or even amplify those biases in its recommendations. A doctor has to be trained to recognize when the AI might be failing their specific patient because of a data deficiency.
And then there's the black box problem.
The black box. Some of these complex neural networks can produce brilliant results, but you can't always trace how they got there. And if you can't understand the why behind a recommendation, how can you really trust it?
It's a huge issue. And all of this relies on massive amounts of data, which brings us to privacy and security.
Of course. And this means doctors need more than just basic IT skills. They need concrete strategies for handling incredibly sensitive information while navigating this tangled web of global regulations.
You're talking about things like IPA in the US.
IPA, the GDPR in Europe, which has comprehensive patient protections, and now the new European AI Act, which specifically targets high-risk medical AI systems. Security and compliance have to become core competencies, just like making a diagnosis.
And all of this circles back to the law. If a human and an AI are making decisions together, that line of accountability gets, well, it gets very blurry.
It gets extremely blurry. And medical school curricula have to address these legal implications head on. If a collaborative diagnosis is wrong, who's responsible?
Is it the doctor who didn't override a flawed suggestion?
Or is it the hospital that implemented the system? Or maybe the developer whose algorithm had some hidden flaw? Training has to define those professional responsibilities in this new shared space.
So the final takeaway is that this won't happen just because the tech is smart.
Not at all. It requires clinicians who can collaborate confidently with AI, but who always prioritize patient safety, equity, ethics, and trust above everything else.
So this deep dive really reinforces one essential truth. The future of medicine is changing its entire focus. It's moving away from that old model of the doctor as the sole keeper of knowledge, the one who relies on memorization.
And moving toward becoming a master of collaboration.
Yeah.
An integrator who uses technology to provide truly holistic care.
But the complexity of those legal and ethical questions, especially around accountability, that remains the central challenge.
It does.
So we'll leave you with this to think about. If an AI system gives flawed advice, maybe it's biased, maybe there's a glitch, and that leads to a patient getting suboptimal care, where does the ultimate professional and legal accountability lie? Is it with AI-augmented physician who signed off on it? Is it with the developer who wrote the code? Or is it somehow with the integrated system itself?
That accountability gap. That is the single most urgent philosophical and legal puzzle that the next decade of medicine absolutely has to solve.